Hello everyone, this is Jebel Sonishabi. Today I'm going to explain you about my seventh experiment, which is implementation of fuzzy C-min clustering. First, we are going to install fuzzy C-mins. So I'm giving pip install fuzzy C-mins. My first question is to import necessary libraries and load the dataset. To import the necessary Python libraries such as pandas, numpy, matplotlib, and scikit-learn, and fcmeans. Importing it, the next thing we are going to load the dataset into the data frame. That we are going to give um, read CSV and giving my dataset is going to be driver FCM dataset. So giving that and printing the head of the dataset. The second question is to fill the imputation, fill missing values with imputation using main. Uh, for that, we are going to fill the empty columns, with empty values with the mean of the data frame. Next question is to standardize the data using standard scalar to standardize the data set. Giving scalar variable to standard scalar and fitting the using fit transform data frame. The next question is to initialize. It is in initialization. Set the number of clusters and fuzziness index, and maximize the number of iteration. So cluster ranges between 2 to 6. N cluster, the number of cluster to form. So EM is going to be the fuzziness parameter. Default is 2. Higher values make the clustering fuzzier. So the M is equal to 2. The maximum iteration. The maximum iteration is defaultly 150. So giving 150. The next question is to visualize the input feature distribution using scatterplot to visualize any two features, which I'm going to give z of 0 and z till 1. So the input feature distribution is going to be this. This is going to be the output. The next question is to perform FCM clustering with different number of clustering in a loop. Perform the FCM clustering with different number of clusters. Use FCM function for FC means library. Predict the label, compute the slot score for each cluster. To find, we are gonna define a column for k in clusters. With FCM, we are gonna give n cluster is equal to k. The m value is going to be m. The maximum iter value is equal to maximum iter. We are fitting x, and label is going to be predict of x. Score is going to be scalar score of x labels, and we are going to append the score into the new column and printing the clusters, the scores. So this is going to be the output. We are getting 2, 3, and 4, 5. So the next question is to plot the Szilard score curve against the number of clusters. So giving clusters, Szilard scores, and mark as circle. So we're gonna give labels and plotting it. The next question is to evaluate the clustering performance. Evaluate the performance of clustering model using slot score, partition coefficient, and partition entropy coefficient for different numbers. For that, giving iteration where FCM is n cluster k, fitting x, giving u as FCM dot u, PC is equal to NP of sum of u power 2 divided by length of x. P is equal to minus NP dot sum of u star NP dot log u divided by length of x. The label is predict of x, and the slot score is x labels. So then we are printing cluster, slot score, partition coefficient, partition entropy. So this is going to be our output. Next, choose the model with optimal number of cluster with higher slot score as the best performing model. Best k is equal to cluster of argument maximum of slot score. Then the best number of cluster is best of k. We are gonna printing it. So this best number of cluster is going to be 3. Then we are gonna visualize the cluster. Use the scatter plot to visualize the cluster with optimal number of cluster, assigning different colors to each cluster for better distinction. FCM is FCM of n labels, which is best of k, and fitting x label is y predict of x, and using scatter plot we are going to give labels and x 0 value and x1 value, and the title is going to be fuzzy C-mean clustering. So this is going to be an output. The next question is to display the cluster centroid. For that, then display the cluster centroid for selected optimal number of clusters. Centroid is equal to FCM dot centers, and we are gonna print the centroid, which is the cluster centers, and we are gonna visualize the center clusters in Tableau. Integrate the visualization in Tableau for optimal number of clusters. So I'm just gonna give a cluster data frame which is labels and importing we are gonna change everything to a CSV, new output CSV, and we are gonna see it in Tableau. So this is going to be the minimum display day. We have displayed over here the sum of mean over speed percentage over given here. So this is going to be the visualization. Thank you.